Oh, okay, yeah. I hope my microphone is working. Okay. Yeah, it seems like it's working. Okay. Okay. So today we have another review. Yeah. Thank you for the feedback. Okay. So yeah, we have another review of the practice midterm. Might be boring, but let me give you another review. So all the questions, for all the questions, I've changed the numbers or the functional form to make it less boring. So yeah, so this one is also uploaded on Canvas. There was a mistake. This number has changed to 2. So if you go to Canvas, in the new version, it should be corrected. Anyway, so let me begin. So first question was about the rank-dependent utility. So yeah, let's begin. So I already uploaded my handwritten answer key on Canvas. So if you missed something, then you can also refer to that one. Okay, so let me go over the first question. So first question is about rank-dependent utility. So yeah, so I will not read the question again. So I'm assuming that you already saw the practice exam. Let me just dive into the question. So assume expected utility with ux equal to square root of x. Okay, so first it is asking, is the function convex or concave? We saw a similar question, right? In the last discussion, I guess. So ux is square root of x, which is x power to 0.5. Is it convex or concave? We need to determine second derivative. And to determine the second derivative, we need to know the first derivative. And then the first derivative is, I take this 0.5 to the ground, which becomes 0.5 times x 0.5. When you take a first derivative, you take -1 at the exponent. And then this becomes 0.5 times x minus 0.5. So when you take another derivative, you just apply the same rule. So we have this guy taken to the ground. And then we will have, let me use color green, 0.5 was already there, times minus 0.5, which is taken to the ground, times x minus 0.5 minus 1. And then we have 0.5 times minus 0.5 is minus 0.25 times x. Let me remove this dot, it might be confusing. X minus 1.5. So first thing to notice that this number is always positive. So this number is always greater than 0. It's good to know that some number power to minus 0.5 or 0.5, these numbers are always positive. It cannot be negative. So some number power to something is always positive. It can be negative in engineering courses, but in economics, we don't think about imaginary numbers. Yeah. So forget what I said. It is positive. This number is a negative number, minus 0.25. So combined, it should be a negative number. Combined, there is a negative number. Any questions? It's not the end of the question. So we are just done with first part of the question. It is a concave function. So it is concave. And then let me separate the spaces. what are expected utility and certainty equivalent? So expected utility. Let me go back to color blue. Expected utility of the lottery, 8, outcome 8 with 0.5, outcome 0 with 50%. To evaluate this one, we evaluate outcome by outcome. So for the first outcome, 8, the utility of getting 8 is square root 8. We multiply 0.5, which is the probability of getting 8, plus 0.5 square root of 0, which is 0. It becomes 0.5 square root of 8 is 0.5. Square root of 8 is 2 square root 2. 2 square root 2, which is 2, because 0.5 and 2 cancels out. Is it too fast? Is it okay? Okay, thank you. So we got the expected utility. Now, what is certainty equivalent? Let me denote certainty equivalent as CE. So U of CE, utility of getting sure value, should equal to expected utility of getting this lottery. So that's the definition of certainty equivalent given a lottery. This was square root of 2. This number is coming from the line above. So CE, let me use color red. This number, U of CE, is just square root of CE. It should equal to square root of 2. So CE should be 2. Just a side note is that it makes sense. Why? Because expected value, expected outcome, yes. So the money that I can expect from this lottery was 4. Why? Because it's 8 times 0.5 plus 0 times 0.5, which is 4. Now, which one is larger, certainty equivalent or the expected outcome? Expected outcome is larger. So the expected money from this lottery is larger. So this is saying that I should expect less. So I'm okay to have a sure outcome that is less than the expected outcome. Why? Because I'm a risk-averse person. I'm a risk-averse person, so I can sacrifice some of the money and get this sure outcome too, which is less than expected value 4. So in this sense, this guy is a risk-averse person. Let's see if this logic works with rank-dependent utility. It will not work. So let's see why it doesn't work. So let us try to get RDU of this lottery. 8 happens with 50%. 0 happens with 50%. Now, we should rank the outcomes first. 8 is better than 0 according to this utility function. So, yeah, so 8 comes first. Let me go step by step. U of 8 comes first. And then we assess the probability of outcome 8. So outcome that is weakly better than 8 is just 8. And then the probability of that one is 0.5. Then nothing is strictly better than 8. So we just take this one. Plus, now the next outcome is 0. And then the probability for 0 is weighted in this way. Everything is better than 0. So we have 100% here minus 0.5, which is just coming from the line above. This is square root of 0.5 times square root of 8, the end, because u of 0 is 0. So this is the end. If I do one more step, square root of, this is square root of 0.5 times 8, which is square root of 4, which is 2. Okay, and then the certainty equivalent should be equal to this rank dependent utility given this lottery. And we computed that the value of this lottery, value of this rank dependent utility is 2. So CE, square root of CE is 2. So CE should be 4. So based on this weighting function W and this utility function, I can say that if I can get 4 for sure, I'm indifferent with this lottery, 8, 0.5, 0, 0.5. But expected value of this lottery is 4, as we computed above. So this guy looks as risk neutral person. So at the above, using expected utility, this guy was risk averse. Let me write it here, risk averse. However, this guy looks as a risk neutral person. How surprising. So if we use rank dependent utility, it might give you a different result compared to expected utility. So a person can be risk averse using expected utility. In here, a person seems as a risk neutral person. Any questions? Okay. Question 2 looks easy. I've put the answer key already on Canvas. So let me skip these questions. And if we have time, then I'll come back. Question 3 is lengthy compared to question 2. So let me deal with this one first. Okay. So if I just briefly review this question, you are already assigned a mark. And then by probability Q, you can exchange the mark for a pen. So you give the mark and get the pen. By probability 1 minus Q, you are stuck with the default choice of the mark. So you just keep the mark. Okay. And then now we have first reference. So there are 2 reference points in this question. So this is different from the homework, or maybe upgraded from the homework. So first reference point, you are trading, you exchange when allowed. So the first reference point is the case where you trade by a probability Q. Okay. So you end up with a pen, and then you keep your mark. So this is the first reference point. Yeah, let me erase everything. Just highlight this. And then the second reference point is the case when you do not exchange. If you do not exchange, then your reference point will be Q1, 0. So you keep the mark plus 1 minus Q1, 0. So this is just a trivially 1, 0, which is you just end up with the mark. Okay. So this is the reason why second reference point R2 is 1, 0. Let me erase this part. Looks redundant. Delete. Okay. Any questions? And also, what is upgraded from the homework is that now utility of the mark is which is a general value. In the homework, I think it was something like 1. Now it is And then utility of getting pen is now UP. So in the homework, I think it was something like you get X dollars. But now you're not getting dollars. You're just trading with pen. You're not selling it. You're just trading with pen. And then in this question, we assume lambda equals to 3. Okay, so this is for the loss, and eta equals to 1. So eta is to account for the gain loss utility overall. Where's this? So first case, we are using the reference point R2. So let us evaluate the utility of exchanging and not exchanging with this reference point. Okay. Any questions so far? Okay. So we will do the same. We will go through the same steps as in the homework. So step 1 that I recommended was evaluating consumption utility. You can also think that this step is recommended by the professor, because when I was writing the answer key, I was just doing everything at one step, and then the professor was saying that no, go step by step. Write consumption utility first, and then gain loss utility, and then add up all the things. So you can also think this as recommendation coming from the professor. Yeah. When I was doing this for the first trial, I was doing it in a kind of wrong way, or maybe misleading way. Anyway, yeah. So step 1, consumption utility. So what do you consume? You will exchange. You will exchange when you're given the chance. You get the chance by probability, different color, red. By you exchange by probability Q. You get a pen, so you get utility UP, and then by probability 1 minus Q, you will not trade. You end up with your mug, and then utility of getting a mug is UN. Okay, so this part, if I write in detail, it will be M. So M is to account for consumption utility. M0, 1, 1 pen. This is for M10. Yeah, let me just write it neatly. So move this guy to here. So Q, consumption utility 0, 1 plus 1 minus Q, consumption utility, need more space. No. Okay, stuck using this technology. Okay. Good. Yeah, so this is the most detailed thing that we can give. So this is how we derived consumption utility based on this question. So this part is straightforward, same as expected utility. What's different from expected utility is that we have gain, loss, utility. In step 3, we will aggregate. Aggregate. Okay, so step 2. So in this case, so the reference point is R2. So the only thing that can happen is that I trade. So by probability Q, probability Q, the outcome is 0, 1. However, my reference point is 1, 0. However, to highlight this fact, let me use color green. However, the reference point is 1, 0, which is R2. So we need to find where the reference point is different from the outcome. Okay, so we found such a case. Hence, the gain loss utility is it happens with probability Q times we multiply eta to account for gain loss utility. And then what is the gain and what is the loss? This one guy, this one pen is the gain. Okay, so that based on the outcome. So, and then the utility for the pen is UP. What's the loss? I was expecting to get this 1 mug, which didn't happen in practice. So that is the loss, minus lambda U of M is the loss. Any question? So let me go to step 3. Then the final answer will be consumption utility Q times UP plus 1 minus QUM plus the gain loss utility Q eta UP minus lambda UM. Final thing to do is to substitute our assumptions. Lambda equals to 3, eta equals to 1. If I do that, we have QUP plus 1 minus QUM plus QUP minus 3UM. Okay, so this is it. Any questions? Okay. And then the second question, show that the reference point, reference dependent utility of not exchanging is UN. Now in this case, reference point, so outcome will be not exchanging. So you just keep the mug. So outcome is always 1 mug and 0 pen. Reference point is R2. What was that? It was 1, 0. So in any cases, reference point and then the outcome is the same. So we just need to care about the consumption utility. You consume 1 mug for sure. So we just need to care about consumption utility, which is 1 mug U of M. So this is the end. Any questions? Okay. Finally, show that not exchanging is a personal equilibrium. So using this reference dependent utility, it is better to not exchange under R2, under this reference point R2. And then find such conditions to make that happen. So the utility of not exchanging should be higher than utility of exchanging, which was here. Paste. Move this guy here. Move this guy here. So this is the inequality we need. This is the utility of not exchanging. This is the utility of exchanging. So we just need to rearrange this inequality. So let me gather all the UMs and all the UPs. So if I take this guy to the left-hand side, then I will have QUM, QUP, QUP minus 3UM. Okay, so we have QQQs everywhere. So I can just cancel that out. Cancel out. I can just erase it. So let me use eraser like this. And then let me move U3 UM, this one to the left-hand side. Then I will have 4 greater than 2 UP. So there are 2 UPs. So yeah, we have 2 UP at the right hand side. So UM should be greater than 2 over 4 UP, which is 1 over 2 UP. Any questions? Okay. Now the next set of question is using different reference point. Just to remind you, R1 was Q. If you trade, you end up with 1 pen. If you don't trade, you end up with 1 log. Let's see. Yeah, looks correct. So now under this reference point, we do the same thing. The utility of exchanging and not exchanging. So if you exchange, then step 1, so always step 1, the consumption utility. Okay, so I almost made a mistake again. So step 1, consumption utility first. What is the consumption utility? In this case, actually, it's the same as this question, this first question. So in this case, I will get Q, I will get 1 pen when I trade. If I do not trade, then I'm just keeping my mark. So my consumption utility is QUP plus 1 minus QUM, which is here, the first part. Step 2 is the gain loss utility. In this case, I'm making a stochastic choice. So by probability Q, I am ending up with 0 and 1. So let me add some notes here. So I'm exchanging, right? And I'm giving my mark and get the pen. By probability 1 minus Q, I'm ending up with 1, 0. So let me just write here to help understanding, keep mark. Now this is the actual outcome, okay? So actual outcome. Now we compare this with what is happening in your mind. How much you are satisfied or dissatisfied. So I was hoping in my mind with probability Q, I will be getting a pen. So no gain, no loss. 0, 1 outcome that I get is the same as my expectation. However, by 1 minus Q, I was hoping to keep my mark. So what is the gain? Gain is here at the reality. Oops. So gain is my pen, UP. Loss is my mark in my mind, UM. Using the same logic for the second outcome, 1, 0. Let me just continue with 1 arrow. So you can see that by probability Q, my expectation, my reference point will be different from the actual outcome, keeping the mark. So what was the outcome? In my mind, I expected to get I expected to get 1 pen. However, it's not true. So the gain is my mark. My loss is the pen that I expected. Okay. So for the part above, the gain loss utility, will be eta q. Where's the q coming from? Q coming from here. 1 minus q. 1 minus q coming from here, okay? And then gain is the pen, okay? Then there's up. And then my loss is a mog. So lambda, to account for the loss, times the utility value, un. Does that make sense? And for here, eta for gain loss utility, 1 minus q for the actual outcome, q for my expectation. I get a mog um. Oh my god, I lost a pen. So lambda up. If I add up these two guys, then it will be eta q 1 minus q up minus lambda plus minus lambda up. Let me continue from above. Then it is eta q 1 minus q 1 minus lambda up plus um. Yeah. And then eta is 1. Lambda is 3, so this is minus -2. So it will give you this second term. So I'll skip step 3. Step 3 is just adding up all the terms, which gives you this equation. Any questions? Okay. Question 5. Show that reference-dependent utility of not exchanging under this R1 is this. Now this one is easier. Looks easier, right? Because there's not much terms involved. Now let's see if it's true. If you don't exchange, then consumption, I was stupid. I can just copy and paste using our science technology. Consumption utility is just Surely keep my mug. Okay. So there's only one outcome to consider. Let me write in this way: 1 mug, 0 pen. In which case you betray your reference point. Let us find out. By probability Q, I trade. By probability 1 minus Q, I keep my mug. Was my expectation. This part, no gain, no loss. We just need to consider the case above. In this case, I gain mug. I feel like I lost a pen, which I hoped. And then the gain loss utility is eta q. I got a mug, so minus I lost a pen, lambda p. This is eta is 1, lambda is 3. So if you add up and this gain loss utility, then you'll have this answer. Any questions? Okay. Last one. Show that exchanging is a personal equilibrium. So this means that exchanging is better. If exchanging is better, then color red. We have Q U P plus 1 minus Q U M minus 2 Q 1 minus Q U P plus U M is better than keeping them not exchanging U M plus Q U M minus 3 U P. This is the answer for one. I'm sorry, answer for question 4. This was answer for question 5. So question 4 should be larger than question 5. Let me send this light blue guy to the right hand side. No. Let me send this guy to the right hand side. So I was just trying to eliminate this UM at the right hand side. To do that, let me move this light blue guy to the right hand side like this. Then we have QUP minus 2Q1 minus, I don't need to write this. Copy and paste. Paste. Not pasted well. Okay. And then at the right hand side, UM is cancelled. We have QUM plus QUM minus 3UP. Then here, I will divide by Q. I will divide each side, left hand side, right hand side by Q. So Q will be gone. So what is left? We have UP minus 2 or minus Q UP plus UM greater than UM plus UM minus 3UP. Not a good handwriting. UP. Continued. Just rearranging. And then let me send this guy to the right hand side. Then we have minus 2, 1 minus Q, UP plus U. So from here, it's not really economics. It's just simple algebra. 2UM minus 4UP. And then continued. We have 2 times 2. So let me divide each side by 2. Divide by 2. Minus 1 minus Q, UP plus UM greater than UM minus 2 UP. And then now it's time to separate Q. So Q, if I separate this blue guy here, it becomes Q UP plus UM minus UP plus UM greater than UM minus 2 UP. Okay, almost done. Send this guy to the right hand side. And then divide each side by UP plus UM. I have 2 UM minus UP. Oh, yeah, it's correct. Yeah, so it's actually from here to here. Actually, you guys are much better than me. I really suck at this simple algebra. I'm really not good at this. But yeah, you guys can also, I think you guys will be much better than me doing this. Anyway, so we got the correct answer. Thanks God. So yeah, this is what I prepared for today. We have 10 minutes left. So yeah, maybe I can go over this question. Yeah. So let me go over question 2 quickly. So in this question, so based on what we learned in the class, you should be stating the reference dependent utility. So based on buying, so we have to consider buying, not buying. If you buy the mug on the reference point of buying, then you just need to think about the consumption utility. And then if you buy the mug, then you sacrifice P dollars, and then you get one mug, one mug. And if you don't buy the mug, then you end up with 0. The 0 is the consumption utility plus eta, and then you save P dollars, and then you sacrifice lambda. You sacrifice one mug, so we multiply lambda here. So this is P minus 3. So if 1 minus P is greater than P minus 1, this is same as, oh, lambda was 3. Oh, I'm sorry. I made a mistake here. It should be 3. I wrote it as 1, which was wrong. It should be 3. So this one is also 3. So then now the inequality becomes 4 being greater than 2P. So we have P less than 2. So this is the first inequality we need. So in the first version of this note, I wrote here as 4. It's wrong. It should be 2. Yeah. In the canvas now, it has been corrected. Anyway, under the reference point of not buying, we also consider 2 cases: not buying and buying. I was going too fast here. So this one, I wanted to mention the reference point. These 2 guys are the outcomes. 1, 2. Outcomes 1. Outcomes. Yeah, it should be eligible at least. This is the too fast. Reference point. Anyway, so going back. If I don't buy on the reference point of not buying, outcome, my expectation is the same. We just need to consider the consumption utility. Consumption utility is 0. So I just verbally explained, but in the exam, if you happen to see this question, then you should explain. Okay. And then the second case, if you buy the mug, you get 1 mug, sacrifice P dollars. And then what is the gain loss utility? You got 1 mug. However, you lose P dollars. Loss is gets penalty lambda. So we multiply this. So this is 1 minus P plus 1 minus 3P, which is 2 minus 4P. So 0 should be larger than 2 minus 4P. So this is 4P being greater than 2. So P should be greater than 1/2. So it satisfies our inequality. Done. Okay, so thank you guys for coming today. So I hope it was not too much boring. If you have any questions, please let me know. Let me end the section. Stop recording.